I want to start our new topic of the binomial theorem by looking at a really interesting pattern. Let's say that I have some letters in a bag. Let's look at this third line. I have two letters in a bag, the letters A and B, and I want to know how many, if I stick my hand and draw something out, how many possible outcomes could I get? So let's say I'm drawing one letter out, and there's two different letters in the bag, so I have two possible outcomes. I could draw out an A, or I could draw out a B. Two different outcomes. Now, if I pick put my hand in the bag and draw two letters out, there's only one possible outcome. I'm going to get an A and I'm going to get a B together. So there's one outcome. I'm going to get an A and a B. Now, let's say I stick in my hand and draw out nothing. Now, you might think, oh, there's 0 ways. But no, we're just going to say there's one way to draw out nothing. Okay, so there's one way to get nothing. All right. Now let's back this up and then think about, what if I only had one letter in the bag? Well, my only two choices is I get nothing or I get one letter. So there's one way to get nothing and there's one way to get one letter. Now let's say there's nothing in the bag. Well, my only outcome is that I'm going to draw out nothing. So there's just one outcome possible here. Those are not terribly interesting, but we need to establish this pattern. Let's go down to where we start getting more letters now. So let's say I have letters A, B, and C. So how many ways can I get 0 letters? 1. Okay, nothing. How many ways can I get 1 out of 3? Well, I could get an A, a B, or a C. So there's 3 different ways to get a letter. How many different ways could I get 2 letters? Well, I could get A and B, I could get A and C, or I could get B and C. Remember, order doesn't matter. It's just that I'm getting a group of 2 letters. Once again, 3 groups of letters that I could get. How many ways to get 3 out of 3? The only thing I can get is all 3 letters, A, B, C. One way. Now let's go to 4. How many ways are there to choose 4 letters out of 4? Or how many ways are there to choose 0, 1, 2, 3, or 4 letters out of 4? 0 out of 4, once again, one way. 4 out of 4, A, B, C, or D. 4 ways. How many ways to get 2 out of 4? Now it's a little more interesting. I have to kind of figure this one out. I could get an A and a B, an A and a C, an A and a D. Okay, I'm done with A's. I've paired up A's with everything else. I could also get a B and a C, a B and a D. Okay, I'm done with B's. I've got B's paired up with everything. So C and D, 6 possible ways to pair up, to draw 2 different letters out of the bag. Once again, order doesn't matter, just a group of 2 letters. How many ways to get 3 out of 4? Well, an easy way to think 3 out of 4 is to think, how many ways to leave one out? Well, I could leave out the D and I could just have an A, B, and C. Or I could leave out the C and I could have A, B, and D. Or I could leave out the B and have A, C, D. Or I could leave out the A and have B, C, D. Once again, 4. And 4 out of 4, A, B, C, D, one way. So you can see this symmetry. We have this 1, 3, 3, 1. Now we have 1, 4, 6, 4, 1. And you're going to see the symmetry, whatever number of letters we would have. But obviously, as we get to higher numbers of letters, this whole counting process gets more cumbersome. So let's look at a mathematical notation, formula, actually, that shows us how to get these numbers, these combinations, every time. So there's 2 different ways in math that this is the 2 different types of notation that's used for this concept of a combination. One of them is NCR, which we read the combination of n select r. And that's the number of ways to select r individuals from a group of size n. This is often the notation used when we're using this as for counting purposes, counting outcomes and probabilities. And that's kind of the way I introduced it by saying, how many different ways are there to draw letters out of a bag? But this is also called the binomial coefficient, and why we'll find out in a minute. And we can write this as n over r with parentheses. Notice there's no fraction bar. It's not a fraction. It's just n select r, and it's just written differently. Recall that n factorial means this number, whatever it is, so say it's 5, you just multiply it times all the integers below it down to 1. 5, 4, 3, 2, 1. Also note that 0 factorial is equal to 1 by definition. Basically saying How many ways are there to select 0 out of 0? 1. Okay, that's kind of our definition. Now here's the formula for a combination. I show both notations, either n select r as the binomial coefficient or n select r as the combination used in probability. But either way, here's the formula. N factorial. So I want you to notice the n is the total number of items from which we are choosing. The r is the number of items from that group. Or so n is the total number of items in the group, and r is the number we're choosing from the group. Notice we take n shows up in the numerator, r shows up in the denominator, and also n minus r. So we have two things in the denominator, n minus r, and n in the numerator, all with factorials after them. Okay, so let's actually do this using the rule. Let's apply the rule to the last sequence that we just did with the 4 letters. So numerator 4 factorial, denominator 4 minus 0 factorial, 0 factorial. So let's evaluate that. Well, this would be 4 factorial over 4 factorial times 0 factorial. Well, 4 factorial is 4 times 3 times 2 times 1. But I also have that in the denominator, 4 times 3 times 2 times 1. So 4 factorial divided by 4 factorial is just 1. And 0 factorial is 1. So this whole thing evaluates to 1, which is what we knew it was supposed to be. Now we do 4 factorial over 4 minus 1 factorial. So I'm just going to write 3 factorial. Okay, that's 4 minus 1. 1 factorial. So this is 4 times 3 times 2 times 1 over 3 times 2, times 2 times 1 times 1. Notice that everything below 4 is just divides out because it's the same in the numerator and the denominator, so I just get 4. So anytime you have 1 as the number you're selecting, the numerator in the denominator will always just cancel out like that, because you're going to have 4, like say if you had 6 select 1, you'd end up with 6 factorial in the numerator and 5 factorial in the denominator, and when you divide you'd end up with just 6. So this is always going to end up like that. 4 select 2. This one's the most interesting of the ones we have, although none of these are terribly interesting because they're kind of small numbers. So this is 4 factorial over 4 minus 2 factorial times 2 factorial, or 4 times 3 times 2 times 1 over 2 times 1 times 2, 2 times 1 times 2 times 1. Clearly I don't really need to write all the 1s in there, so feel free to leave them out if you want to. Notice the whole denominator multiplies to give me 4. So this just gives me 6 in the numerator, which is, of course, what I knew it was supposed to be. Now this one is 4 factorial over 4 minus 3 factorial, 1 factorial, times 3 factorial. Notice that these two are the same because all I did was reorder the multiplication in the denominator, but it's still going to be the very same result when I divide. So this is 4. And this would be 4 factorial over 4 minus 4, which is 0 factorial, 4 factorial. This is the same as the first. Once again, just evaluating to equal 1. That's just supposed to say same as the first, not same as the list. So let's try that again. Same as the first. Okay, so same as the first one. All right, so this shows you how the factorial formula works, or not the factorial, sorry, the formula for finding the combination or the binomial coefficient works. Let's do one more that's a little more interesting. How about 8 select 3 or 8, 3, like that? Okay, so let's do 8 factorial over 8 minus 3, 5 factorial, 3 factorial. Now I'm going to show you, I'm going to show you 2 ways. Okay, so 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 5 times 4 times 3 times 2 times 1 times 3 times 2 times 1. Now what I want you to notice is I have a 5 factorial in the denominator, but I also have a 5 factorial in the numerator. All of that's going to just divide out. I have a 3 times 2 times 1, which is 6, and I have a 6 in the numerator. So all of this is going to end up equaling 56. So here's the way I usually write it when I'm simplifying it. So instead of writing it completely out, I write 8 times 7 times 6 times 5 factorial, because that's going to get me the rest of the way down, and that matches the 5 factorial in the denominator. Then I do the 3 times 2 times 1. So I can just eliminate the 5 factorial without writing it all out. So that's perfectly good if you want to do it that way. Okay, so that is the combination or the binomial coefficient.